measurement. And third thing, we have to represent that measurement of physical quantity with proper unit. Now, we discussed about fundamental or base physical quantities and their units are defined. Now, all other physical quantities which we will use, then as per discussed previously about derived physical quantities, all those derived physical quantities will be defined later on in different chapters as those physical quantities appears in different chapters. So, out of our 3 requirements, 2 are fulfilled now, or we can say now about 2 the discussion is already carried out. Physical quantities and their units. Now we have to think about measurement. So here actually we have 7 fundamental physical quantities or 7 base quantities, okay, and their 7 units are defined. But if we think about measurements, then here measurement for length, mass and time, that is included in your syllabus. Measurement of electric current, thermodynamic temperature, amount of substance and luminous intensity is not included here. So now let's first discuss measurement of length. Okay, now we already discussed this thing. The unit of length, that is meter. Unit of length, that is meter. Okay, now unit means standard measure of any physical quantity. So suppose we have meter bar. Now with the help of that meter scale, okay, the smallest possible measurement is how much and the largest possible measurement is how much. First of all, that we have to understand. Okay, now on meter scale there are 100 divisions. Each division stands for 1 centimeter, and per each centimeter 10 small divisions are there. It implies that we can say here each division stands for 1 millimeter, because the total small divisions in a meter scale, that is 1000. Okay, so one division have the value that is 1 upon 1000 meter. So that is 10 raised to minus 3 meter. But that 10 raised to minus 3 multiple, that is actually called submultiple. That is named as milli. Okay, so we can say that small division stands for 1 millimeter. Okay, now with the help of meter scale, the largest possible measurement is how much. તમે વધારેમાં વધારે કેટલું ડિસ્ટન્સ ઓર લેન્થ મેઝર કરી શકો? તો few meter. આપણે એવું કહી શકીએ 25, 50, 100 મીટર સુધી આપણે ડિસ્ટન્સ કે લેન્થ મેઝર કરવી હોય તો મીટર સ્કેલ થી તમે મેઝર કરી લો. But if you want to measure the distance between Ahmedabad and Baroda, Ahmedabad and Mumbai, can we use meter scale?
No, sir.
No, sir.
We can't use it.
We can
Okay.
use
Now, with the help of meter scale, the smallest possible measurement, that is 1 મિલીમીટર, કારણ કે મીટર સ્કેલ ઉપર નાનામાં નાનો ડિવિઝન જે છે એ 1 મિલીમીટરનો છે. એટલે 1 મિલીમીટર કે 1 મિલીમીટરથી મોટું મેઝરમેન્ટ હોય તો આપણે મીટર સ્કેલનો યુઝ કરી શકીએ. ઓકે, તો હવે મીટર સ્કેલની આ લિમિટેશન્સ આપણે સમજ્યા. હવે જો suppose we want to take measurement which one is smaller than 10 raised to minus 3 meter, then what to do? Then there is one instrument named as vernier calipers. આ વર્નિયર કેલિપર જે છે એનો એક્સપેરિમેન્ટ તમારા સિલેબસમાં છે. એટલે સ્કૂલ ચાલુ થશે અને જેવી લેબ ચાલુ થશે એટલે પહેલો જ એક્સપેરિમેન્ટ તમારે આ વર્નિયર કેલિપર્સનો આવશે. ઓકે, so that is the instrument with the help of which one can take the measurement of the order of 10 raised to minus 4 meter. હવે સપોઝ એનાથી પણ નાનું મેઝરમેન્ટ લેવું હોય 10 raised to minus 5 meter. So another device is there named as micrometer screw or microscope, and another one is a spherometer. So with the help of all these instruments you can take the measurement up to 10 raised to minus 5 meter. હવે વસ્તુ એ છે કે જો આપણે few meter થી લાર્જ મેઝરમેન્ટ લેવું હોય એટલે હવે આપણે સિમ્પલી એવું કહ્યું મેં તમને કે ભાઈ અમદાવાદથી મુંબઈ કે દિલ્હી કે એવું મેઝરમેન્ટ લેવું, અથવા તો એનાથી બી આગળ જઈએ. ઇફ યુ વોન્ટ ટુ ટેક ધ measurement of the distance between earth and moon, તો સ્કેલ લઈને સીડી મૂકીને ચડી જવાનું એમ હોતું હશે, બરોબર છે. પછી સપોઝ વી વોન્ટ ટુ ટેક ધ measurement for the size of molecule, atom, nucleus, so directly we can't measure it. It implies that now if you want to measure very very large distances or lengths, or very small distances or lengths, then we have to think about some alternative methods. We have to think about some alternative methods. Okay, now here first we have to discuss the method for the measurement of large distances, and this particular method of the measurement of large distances, that is called parallax method. Okay, so now we have to discuss parallax method. Now parallax means what? So if we observe any object from two different positions, right? Suppose if we keep a pencil like this, and then after if we observe it with one eye, means with right eye, and then after with left eye, then we feel this thing, its positions changes. This is called parallax. This is called parallax. And the distance between the 2 points of observations, that is called basis. That is called basis. Okay, now suppose we want to measure the distance between earth and planet, between earth and planet. So now what we have to do here, we have to fix two positions at the surface of the earth, and now from these two positions we have to fix two directions at the planet. So see here in the figure, one position at the surface of the earth, that is A, and one direction fixed, that is AP direction. Then another point at the surface of the earth fixed, that is B, and another direction up to planet is fixed, that is BP. Now the distance between these 2 points of observations, that is called bases, it is denoted by B. Now angle subtended at the planet by this base, here it is represented as theta. This theta is called parallax angle, is called parallax angle. Okay, now we already discussed angle, that is arc upon radius. So if we imagine a circle, large circle will be formed by taking planet P as a center, and now if we consider this base, which one is on the circumference of the circle, then that will be very small part, because distance between earth and planet, that is too much large compared to this distance. So we can treat this particular distance A to B as an arc. So we can say angle, that is arc upon radius. So angle theta, that is arc, is B, and radius, that is the distance between earth and planet. Suppose we denote it by capital D, then we can write angle theta, that is B by D. Therefore the distance D equal to B by theta, that is B by theta. Okay, now with the help of this equation, one can easily calculate the distance between earth and any other planet, or earth and moon, earth and sun, like that. Clear to all of you?
Yes, sir.
Good.
Yes, sir.
Yes, sir.
After, once you calculate the distance between earth and that planet, then after you can predict the size of that planet also. How? Say, once you measure the distance between earth and planet, then after, means now this D is calculated. Then after, what we have to do? Then after, to calculate the size of the planet, to measure the size of the planet, what we have to do? From any one position at the surface of the earth, we have to fix 2 directions as shown in the figure, which are tangential to the planet. Means કે એવી 2 ડાયરેક્શન આપણે આ એક પોઝિશનમાંથી ફિક્સ કરવાની કે એ ડાયરેક્શન્સ આ પ્લેનેટની સરફેસને જસ્ટ ટચ કરીને જતી હોય. તો એવી 2 ડાયરેક્શન્સ અહીંયા આપણે ફિક્સ કરીએ, રાઈટ? તો આ પ્લેનેટની સરફેસ ઉપર જ્યાં આપણી ડાયરેક્શન્સ ટચ થતી હોય એ 2 પોઈન્ટ્સને જો આપણે જોઈન કરી દઈએ, then that will give you the diameter of the planet. So now again we can say the diameter of the planet subtend an angle alpha at this particular position at the surface of the earth. So again we can write angle, that is arc upon radius. Radius, that is nothing but the distance between earth and that planet. We already calculated in parallax method. Now we have capital D. This alpha that we have to measure at the surface of the earth. Clear? So alpha is measured, D is already calculated. So now make D small, small d as a subject of equation, then we can write a small d, that is alpha d. Substitute the value of alpha and capital D in this equation. You will get the diameter of that planet. અને આને રિલેટેડ આપણે એક્ઝામ્પલ્સ કરીશું હવે, એટલે તમને વધારે ડિટેલની અંદર સમજ પડી જશે આની કે હાઉ ટુ યુઝ